All right, so let's get this party started, huh? Today we're talking about prepaid forwards and option bounds. It's going to be really nice. Hopefully that we'll be able to um, kind of put some things in perspective here. I remember when I was preparing for this exam by myself, like all this was kind of a big mystery to me. Like even like prepaid forwards, why do we care? Like yeah, they're kind of in the formulas, but it turns out that they're really a pretty awesome thing to know about. So hopefully we'll be able to share that with you guys today. So if you have any feedback about the last seminar, please feel free to email me or send a chat or whatever, good or bad or whatever. If you'd like other things that you thought might be good to include in there, that'd be great too. But it'll be basically the format as yesterday. We'll go through these slides together. Hopefully you've got the link and you can either download them or put them on your tablet or something and have some more to write on there. So just kind of complete these together. It's better than just watching. It's kind of good to like kind of be active with it. So if you can kind of write, I try to make them sort of interactive in a way. And again, just like last time, if you have any questions, feel free to chat them, or if you want to unmute, that's cool too. I'm happy to do that. So it's being recorded, so we should be able to have a copy of this for later too, in case we go kind of fast through something. Okay. All right, so yes, let's get started here. So today we're going to first talk about prepaid forwards. And I know I hyped these up yesterday. I said, oh, they're super important. They're so critical. But it's really important just to kind of see how they relate back to the FM exam. They're like a really cool parallel back to FM. Okay, so what exactly do they give you? Well, we talked about yesterday, we even had the same diagram. Said that if we were standing right here, the forward price, what did the forward price do? Well, the forward price was the price that you would expect to pay in the end to receive exactly 1x in the end. But you'd only have information available at time t to be a little t to do that. But a prepaid forward, then the only thing different is you're just going to pay it now versus paying it later. That's it. Okay, so I know it's not really that groundbreaking right here, but it's the amount paid at time little t in order to receive exactly 1x, whatever it is, at time capital T using information available at time little t. Okay, so basically, if you look back what we did in seminar 1, the only difference is when you pay. Do you pay now or do you pay later? So it doesn't seem that great, but why is it so important? Now here, this is the important part on this slide. Why is something like this so important? Well, because if we think back to FM, what we did is, you had money and you kind of moved it around. You're like, oh, if I had, compound interest, I know how to move it back. You do like 100 v to the whatever, or e to the negative, something, or force of interest or something. So we could move money around in time, backwards and forwards, no problem. But when the thing that I would like to sort of like move back and find the equivalent value back in time is not a dollar amount, well, suddenly it's a much more complicated thing. If I wanted to move this X back in time, and I'd be like, oh, okay, well, how much should I pay now to be equivalent to that 1X later? It's not so easy. But what it is actually, it's the prepaid forward price. The prepaid forward is the means by which we can take non-money things back in time. We can sort of move those around just like we did back in FM. So it is the means by which you move non-money assets back in time. Super powerful connection to make, because a lot of these things we talk about, risk neutral pricing, and we try to, as actuaries, we want to try to find out like, okay, what's the current value of that equivalent thing later? We can't just always automatically discount with interest. That's not what we do. If it's a dollar amount, a fixed dollar amount, yeah, totally, I could do that. Or even like the cost of capital or whatever, that's cool. Like maybe we can do things, they give us a value like that. But what if it's like a share of stock? I'm not going to take, first of all, I won't know the future price and then try to discount it with interest. That's not how I find like sort of the equivalent value now for that. The way that I do that, the mechanism is a prepaid forward. So we can think of it sort of mechanically, like we like back in FM, we're just moving money forwards and backwards. But this is going to be such a huge thing because now on this exam, like never before, we are dealing with a ton of things that aren't a fixed dollar amount. Okay, we're going to see all sorts of things that we're going to apply this to in the next seminars. Now, the cool thing is, like what we said too, the forward and the prepaid forward, the only thing different is when we pay. It's always the same amount basically, but it's just like when we pay. So those two things are always related through interest. So no matter what it is, whatever object it is, the forward compared to the prepaid forward is just through interest. So for that, we can actually say here that the prepaid forward is whatever the forward price is, but back in time. So you'd have to go e to the negative r and times the distance in time or whatever, that's fine. Or if it's effective interest, you could do it that way. Okay. Now let's look at a couple of prepaid forwards that are going to come up today, and then we'll see some more examples in the next couple of, I think seminar 4 and 5 especially, we're going to have some more interesting things that we're going to do this with too. But again, it's just this way that we kind of move things back in time if they're not money. So if it is a fixed dollar amount, great. If it is a fixed dollar amount, then that I can actually just move back with interest, because basically the prepaid forward is like, oh, how much should I spend now in order to get that later? And we're like, oh yeah, k e to the negative r times time. Right, super easy. If it's a stock with no dividends, so again, if I'm at time little t, if I have a stock with no dividends, well, if I want to receive exactly 1 share of stock at time capital T, how much should I pay now to be able to do that? And actually, we just we just pay the current price. That's it. Because if we pay the price now but get it later, there's really no like benefit to us actually having the stock, really. Unless, I mean, if there's no dividends, there's no real incentive for us to hold the stock. We can get it later too, it's no problem. So this would actually just be current price, ST. So again, we're right here. What about if the stock has discrete dividends? Well, we could kind of go the same way, and we're like, well, if I mean, if I want to get exactly 1 share later, I could actually pay the current price. But if you did that, that's a little bit wrong, because you wouldn't receive the stock till later, but you'd pay full price now. So you're like, okay, I'm going to pay full price, but somebody else is going to keep the stock. But if there's dividends in there, they're going to get the share, they're going to get those dividends. You paid full price, but they're getting the dividends, and then they're going to give it to you later. Like, you should really get credited for those dividends that you're not getting because you're spending full price. So that's why they sort of discount here. They will subtract off the present value of the dividends that would be within that time period that you wouldn't get. Makes sense. And then what if the stock pays continuous dividends? Well, basically same kind of reasoning. If I were to pay full price now, remember what we talked about yesterday about the dividends. If dividends are continuously, paid, it really just means you end up with more shares of the same stock. So we're saying like, oh, okay, if we basically paid full price now, but we didn't really get a hold of the stock, but then they only give us exactly 1 share later. Well, that's not fair, because if we would have just purchased the share of stock, we would have got more shares of that stock. Over that time period, we would have accumulated dividends or more shares of the same stock in order to be able to, so we would have kind of like maybe a little bit more than a share of stock. So they're like, well, okay, well, that's not really fair. I mean, you're paying full price now. You should really be able to kind of get credited for that. So what they'll do is they will still just sort of like discount it, kind of like we did yesterday when they tailed the stock. They're going to say, well, why don't you just spend basically the same as a little bit less than a share of stock, so that it'll accumulate to exactly 1 share of stock. So that's why we have this e to the negative delta times time. So that's it. They're just saying like, okay, you shouldn't have to pay full price, but then not get the benefits of the dividends you would have received through that. So we'll just credit you with those dividends, basically charge you the same as a little bit less than a share of stock, so that it would have accumulated to exactly the same for you. That's all they're doing. That's it. So we can kind of think of like, yeah, if I had one S capital T and I wanted to take it back, well, depending on the situation, the way that I would sort of move it back, I'm not, discounting it with interest or something. I'm not discounting it with dividends. I'm actually using a totally separate set of formulas in that situation, right? But that is so, but we're abstracting this idea about moving things back in time. And we're just calling it the prepaid forward, but that's really all it's doing is it's just abstracting that idea. The thing that we did all the time back in FM, but now we're kind of doing it with non-money things. Okay. And you could even think of it with currencies. We're going to have some currency stuff today, so hopefully that'll be a good thing to look at. But so how would I do the prepaid forward of 1 yen? Okay, so I'm gonna show you maybe a slightly different way to do these ones, but just because they can kind of mess you up in the questions. Okay, so I'll show you what I'm saying. But so what if we live in the US, but we would like to know the prepaid forward of 1 yen? Okay, well, what do we need to do? So basically in this situation, I've got 1 yen right here. And if you want, you can put the 2 little lines, but honestly, as long as you know what you're dealing with. So I'll put it here just for us, but if I were to do it, I probably wouldn't put those little lines. I'd probably just call it 1Y just to keep it simple. But all right, we want to know, well, how do I discount that back in time? Well, the cool thing is that it is actually a yen. So it is a fixed dollar amount, but in Japan, right? So so we've got 1 yen is going to be discounted back. So 1 yen will be discounted back. So that's a 1. So 1 yen will be discounted back by its rate, R yen, times the time. So if I was over there, great. I would just discount that with my risk-free rate interest over there. But because it's in the US, I then need to sort of like convert it to what my dollars are now. So they have this conversion here. They say, like, oh, every dollar is worth 100 yens. So the way that I do that, whenever it deals with currencies, I put the little currencies there as like sort of like a units for me, because I'm always going to, the key to getting those right is to keep track of those units. And we can think back to maybe back in science class, if you had science class and they're like, oh, okay, I've got 24 or 28 yards. Oh, sorry, 28 feet, let's say, and I wanted to know how many yards that is. I don't know if you ever did this, but sometimes one way to do that is just to sort of multiply it by, well, I guess the number of feet per yard, because then the feet will cancel, my units will be yards. So I'm going to do this all the time. But then in this fraction, you could say, oh, how many feet was equal to how many yards? And we had that 1 yard was 3 feet. So this thing would actually be 28 thirds yards. But we're going to do this with currencies too. I'm actually going to, if I'm in the US, my final answer has to be dollars. So I'm going to want to kind of, in this case, get rid of the yens, cancel those basically, and put it in dollars. And so I just need to know, oh, how many dollars was how many yens? $1 for 100 yens. And so then that would be my answer, 1 over 100 e to the negative r yen times time. And we'll have a lot more with that as we come up, but it's basically the same thing. You're just like, okay, if I wanted to discount that in time, what's the appropriate way to do that? Okay. Oh, and then we have a question here. It says, could you compare the forward and prepaid forward price again for the stock that pays continuous dividends? Yes. So the forward price, we can actually go back to this idea that the forward and prepaid forward are just related through interest. So basically, if I have the forward price here, I can discount it with interest to get the prepaid forward, or if I had the prepaid forward, I could move it ahead with interest to get the forward price. So we can actually, since we know the prepaid forward for a stock with continuous dividends, we can move it forward now. So the forward price would just be this one, the prepaid forward, negative delta times time, but then times interest to move it forward. So I guess I times e to the r times time, right? So that's the only difference. I would do that. And then when we see, yes, we can combine these together. And this really would just give me, so STE to the r minus delta times time. And that's what we had for the price before for stocks. Sometimes we put little t as time zero if it's like kind of at the beginning, just for a simpler looking formula. So sometimes we might say S0 e to the r minus delta times time. That's fine too. It's the same. It's just like if little t was zero. But it is, yeah, it's just the same thing. We're just moving it forward with interest. So actually, instead of remembering the forward prices, I mean, those are important and it's not too hard to remember. But I actually, the prepaid forwards are going to become much more important to us. But the nice thing is if I know the prepaid forwards, I automatically know the forward prices because it's just the prepaid forward plus interest, basically. And I thought that that would be a good question to ask on the test, to be honest, is if they kind of gave you some information and you could find the prepaid forward, but then they gave you interest as like maybe effective or compound quarterly or something like that. Because we get so used to this formula here for that we need like continuously compounded interest to be able to do that, the little r. And you could convert their interest to that. But the other thing that you could do if you wanted is, well, if it was like effective interest, then you could actually, instead of doing this term here, you could just multiply by 1 plus I to the time, you know. You could do something like that. It's just moving it forward in time. So you're just basically accumulating with interest, whatever interest they have. But I don't know, I kind of thought that it'd be probably not too hard to design a question that could exploit whether or not somebody really knows that. So, but at any rate, any other questions on this page? Yeah, thanks for asking that, by the way. I appreciate that. Okay. All right, so let's look at an example, just a quick one here about this. So it says here, a stock has a current price of X and just paid one of its quarterly dividends. Okay, so got it. And then over the next year, dividends will remain constant at 0.025X. 1 year prepaid forward costs 72.29 and a 1 year forward costs 76.73. Determine X. All right. So whenever they have discrete dividends, I actually draw a little timeline just like you did back in FM. And it looks like they're really just going over 1 year here. So here's 0 to 1. And it's got these quarterly dividends. They said the current price is X, and then each of the dividends is 0.025X. All right, and then they told me that the prepaid forward on the stock was 72.29 and the forward price was 76.73. All right, now we know that these two prices are just related through interest. So what kind of interest rate would you use here? Would you do the R, the continuously compounded? Would you do effective? What would you do? I think what I would do is I think I would use a quarterly rate because I kind of feel like I'm probably going to have to do something with like an annuity angle 4 or something, or S angle 4. And it'd be nice to have the quarterly rate. So I'm going to do that. I'm going to actually use the quarterly rate here. I feel like that's going to be a little bit easier to work with. And I realize that these two are just related through a year's worth of interest. So I'm going to have here that 72.29 times 1 plus j to the 4th is equal to 76.73. All right, and let me find j here. So that seems pretty straightforward. 76.73 divided by 72.29 raised to the 1/4. And I got that j was about 1.5%, 0.01501. But I'm going to store it into X. I don't know how sensitive the answers are going to be here, but just like we talked about yesterday, I'll kind of use these registers in the calculator as much as possible. Yes, I can scroll back up to it, but it's just going to be nicer within calculations to maybe be able to use the X just a little quicker and simpler looking, even when you go back to try to edit formulas and stuff. Just using the variables is nice. And so then so now we want to find X. So to find X, I could use, well, I guess I'm going to have to use one of these somehow. So I like the prepaid forward a little bit better. And that's kind of nice because if it was the forward price, I would take the X forward and then minus all of these forward, which is fine. I could do that. And that should be equal to the 76.73. Or I could do the prepaid forward, which is current price minus dividend. So I think that one's going to be a little bit simpler. So let's do that. Let's do 72.29 is X minus, well, that 0.025X A angle 4 at that rate J. And actually from here, I can solve this pretty easy. So by the way, I put the X with a box around it because in this equation, they also have X's, but I realize it's not the same X, right? That's one of the reasons I like the box, just to say, oh, that's in the calculator, and it just kind of feels a little different anyway. So, but okay, well, let's do that. So I've got X times 1 minus 0.025 times, all right, 1 minus V to the 4 over J. And for the J, that's really my X. So I'm actually going to say X times 1 minus 0.025 times 1 minus 1 plus X to the negative 4 over X with the box. And actually I'll be able to get the X in the problem a lot better here. So let me compute that out. 1 minus 0.025 times. Oh, another thing on the calculator, I'm not sure if you know about this or if you use it, but I use the fraction key a lot. See the N over D key on the third row down and the second one over, especially if you're using this one. If you're using the 32S, I don't think it has this feature, but on this one, see right here, the right there, N over D. If you press that, it'll put a fraction thing on there, which is nice because then that just kind of makes it a little bit simpler to see. And honestly, that's really all we're after here is we just want it to be simple for us. Like we don't feel that we're, it's kind of like beneath us to use something like that. We don't think of that at all. So yeah, and then so good. So if we do this here, what do you find? Sorry. Okay, so 1 minus 0.025 times fraction 1 minus parentheses 1 plus X to the negative 4 over X. And I got like 0.9036 for all that. And then I'll just take 72.29 divided by that. And find out that my X is basically $80. So. And so we got that. So the X that they were looking for was 80. Okay, and then just a question here about, does anybody have a good way to remember the A angle N and S angle N? I think that might be kind of what the question was, the present future values. I just kind of remember the formulas that we used back in FM where it was like A angle N was 1 minus V to the N over I, and then S angle N was just the 1 plus I to the N minus 1 over I. So I just kind of remember those formulas. That's what I do. But if anybody has a good way to remember them, feel free to just chat it or say it out loud. That's cool too. A pretty cool problem, right? It's actually pretty easy, just realizing that the prepaid forwards and forwards are just connected through interest. You can use whatever interest that you want. For us, it actually felt a little maybe more convenient to use J. Don't feel like you have to use I. You could, but then you'd have to convert and it just becomes more problems. You could use continuous because they sort of do a lot, but it just seems for us that probably would have been a little bit more helpful for quarterly interest. Okay. Yeah, good. All right. Now, let's go on to put call stuff. So put call parity, put call duality, things like that. Now, for us, I want to look at calls and puts in a slightly different way. Okay, and we can look at it as a stock, a strike, and time. In fact, sometimes we use a little bit expanded way to write a call or a put, right? Sometimes we just do call with strike K, but sometimes we want to be a little bit more specific, or maybe the parameters are a little bit more general. We'll actually use this 3-parameter version for a call, but it's okay. Usually this is kind of like the stock, the strike, and time, like usually that would be the 3 parameters for this expanded way to write it, but it's just, sometimes you can use a simplified, sometimes we actually just do C minus P, right? So sometimes we don't even write the strike in there either if it's easy enough. But okay, so we have this thing here. Now I want to look at this because we're going to start to go outside of the typical things like stock, strike, time. Well, but what if you have like stock time, or even like currency time or something? We want to try to abstract this idea here too in a way that's going to be really nice. So, all right, how do we want to think of a call? Well, so if it's a stock and a strike, we know the definition where it's an option to buy. So if the stock goes above the strike, we're gonna buy the stock for the strike, right? That's the thing. So we are going to, if you think about what we give and what we receive, what we give and what we get, in that case, stock, we would pay the strike to get the stock. So we would give the strike, we would give B to get A, so the stock, if it's a stock and a strike. And we could even put on here when, if I guess the stock would be, the stock A would be more than the strike. Right, that's kind of when we would do it in that case. And for, so when I think of this, the way that I want to think of this to myself is that I'm going to give away the second parameter to get the first parameter. So I'm going to get the first parameter and give away the second one. And that actually is why it's called a call, because you're kind of like calling the stock to you, right? That's the idea. Now with a put, we're going to see it's the opposite. But what's a put? Well, that's going to be where you're going to, so that's an option to sell. So you're going to sell the stock for a certain price. So there you're going to receive the strike, you're going to receive the money, the strike, and you're going to sell the stock, you're going to give away the stock. So you're going to give away the first parameter to get the second parameter. And when would you do that? Well, again, when it's advantageous, I guess that's where the strike is higher than the stock. So if the strike B is more than A. In other words, you're going to give away A, you're going to put A away from you to receive B. Okay, but notice how the idea is like completely parallel. And in fact, if you actually were to switch every A for B, if you were to call this B, A, B, notice it would actually be the exact same thing as a call. So if we were to switch the B and the A, it's actually a call. The exact same call, all the features are the same. So a call with ABT would be the same as put with BAT. All I do is just switch those first two parameters, and a call is exactly the same as a put. They really are completely parallel ideas, which is pretty awesome. In fact, they call that the duality, that every call could be written as a put, every put could be written as a call. Now, it's just usually we don't do it because we like to see the stock first and then the strike second. And so it feels a little weird if it was the strike first and stuff, like we just never see that. But you could totally do that and it's totally fine. Yeah, totally fine to do that. And then put call parity, we know, well, maybe the one that you might have is for a call with stock strike time. So I'll kind of write this one here, stock strike time minus put stock strike time. And maybe the formula that you have, I've seen some books do some really terrible things here. Some of them do this, don't write this, but some of them put S0 minus KE to the negative RT. I've seen that in books saying, hey, this is the book called parity. But that's actually not right. Like that's not the thing you want to remember, but I remember seeing that. But actually, probably a lot might say this, SE to the negative delta T, sorry, not R, SE to the negative delta T minus KE to the negative RT. And that's okay. I think that's okay to remember, but I don't think that's the best one to remember. I think it's better to be more general and then to be able to specifically do this one here to be able to apply it here at this specific case for that specific situation, a stock and a strike. So I'm actually going to remember prepaid forward of the stock minus prepaid forward, prepaid forward of A minus prepaid forward of B. So to me, this is the better thing to remember. Okay, and I'll always use this because it's like the Swiss Army knife, right? This formula works in every situation, particularly this one. And honestly, if you already have that one memorized, then hey, it's no harm, no foul. It's already there. If it is stock and a strike, which honestly it is most of the time anyway, remember that formula there. That's cool. But it doesn't have to be. It could be two stocks, or it could be currencies, or it could be, it could be anything, or even like a stock with discrete dividends instead of continuous ones. The more general formula is that actually it's just the prepaid forward of the first thing minus the prepaid forward of the second thing. That's what the put call parity is in general. So I'm going to remember that. And I think that's probably the best for you guys to remember also. So if it is a stock with whatever kind of dividends, stock with no dividends, discrete dividends, or continuous, you got it. And if it's just a K, then yeah, the prepaid forward on K, a fixed dollar amount, is just K less interest. Done. So let's see how this is going to help us here in the next couple of problems. Okay. And then any questions about this? Because it's an important sort of idea here. Okay, but I'm trying to help with like, yeah, let's look at these maybe just a little bit at a higher level here so that we can see how they fit with other contexts. It's actually really cool. You're going to see it's going to be great. Okay. All right, so let's look at this. We had stock S, it has a current price of 40 and an annual dividend of, okay, so discrete dividends, $2.95, the next being paid in 4 months. Okay, so let me just kind of write that on here. Current price of 40, and then 4 months later, $2.95, and it's annual. So maybe if this is like a 2-year or 3-year, might have to do it a bunch of times. Well, let's see what we have here. So there's times 0. So then stock Q, well, maybe I'll write S there for that. Stock Q has a current price of 75, pays continuous dividends. Okay, so that's good. At a rate of 4%. An option that allows you to exchange 2 shares of S for 1 share of Q in 1 year costs $5.43. Okay, so this is what they call an exchange option. And it's not a stock with a strike, but it's a stock with a stock. Okay, and that's what an exchange option is. You're going to exchange one stock for another stock if it's beneficial to you somehow. Now, we just saw that by the put call duality, any call can be thought of as a put, and any put can be thought of as a call. So the only thing is we just need to know, we have to kind of pick one and say like this situation here, where this exchanging 2 shares of this for 1 share of that. Okay, we just need to know which one is that for me, a call or a put. I can actually pick whichever one I want as long as I'm consistent with what the first parameter and second parameter are. So I'm gonna just think in terms of calls. I don't know about you, but I feel like those are a little bit easier to handle. So I've just got these, the time is 1 year, so that's good. And I just need to know, well, do I go like 2S and 1Q, or is it the other way around? And this is always the issue here. We just need to know what, and you can kind of memorize if you want, but let's see if we can think our way through it. So let's think about exchanging, this word exchange. It allows me to exchange 2 of this for 1 of that. So we can think of ourselves going to Starbucks. We're like, oh, okay, when you go to Starbucks and you buy coffee, what do you exchange? Well, I don't know about you, but I exchange money for coffee, right? That's what we do. So we give away the money to receive the coffee. We wouldn't really say we exchange coffee for money. We would say, from our point of view, we exchange money for coffee. So the first thing we give away, and the second thing we receive. So that's exactly what it is here. 2 shares we're going to give away, but we're going to receive 1 share of Q. So for a call, remember what it was? The first parameter was the thing that we called to us, and the second one was the thing we gave away. So if we were to write this situation for us, we would say that it is a call where we receive 1Q, we call 1Q to us to give away 2 S's. And this option here costs $5.43. Okay. So good. Yeah, and then you could also think, yeah, oh, somebody has a great idea here too. Could you think of like exchange being equivalent to give? And yeah, I think that would actually be a great way to think of it. Like give 2 shares for that. And if you ever have questions, sometimes it might sort of phrase things a little bit weird, but yeah, kind of think back to that like Starbucks example, or maybe not Starbucks, whatever you like, you know, Panera or whatever. Just think about what it means to exchange something for there. I remember that, like I thought myself in so many circles with that, like exchange 1 for S, you know, 1Q for 2S, and you're just like, okay, which one am I actually getting? And I'd get it right half the time and get it wrong half the time. So I don't know if you guys are kind of like that too, but that happened to me. Okay, but at any rate, so now that we know that, we can look at the second one too, though. So an option that allows you to exchange half a share of Q for 1 share of S in a year costs $3.77. So I'm going to think of that as a call again. And now that we did the hard work, we realize we're going to give away 0.5 Qs and receive 1 S. And I'm going to think of that and I'm like, oh, I'm going to give that one away, receive this one to me, totally fine, in a year, and that costs $3.77. Now you could have done either of these as a put. It would just have the things reversed, right? Because a put will put this thing away. So it would have been a put with the 2 shares of S and 1 Q. So you could have done that too if you wanted. For either of those, it's no problem. Okay. Now we're going to end up doing something like that, but yeah, with either of these, the liberty is up to you, whichever one you want. Okay. So we look at this and we're like, all right, they kind of give me a call and well, 2 calls here, basically. But well, I can't really do much with this. But if I were to sort of maybe like line up to maybe have maybe all the Q's first and all the S's second, that might be kind of nice. So maybe what I'll do is I'll just do the put call duality on this just to switch these 2 parameters. And I'm going to actually call this a put with 0.5 Q's and 1 S in 1 year. So that's at least a little bit better. I've got the Q's first and the S's second, but they're not really exactly the same parameters because in the first one I've got 1Q, 2 S's, and then the second one I've got half a Q and 1 S, or yeah, half a Q and 1 S. So I'd really like to maybe like double this one. So the cool part is that you can actually just double a call or a put, and it'll double kind of like the things that you're receiving and getting. You're not going to like double the time, right? It doesn't make it twice as long. It just makes it over twice as much. So there's kind of like a nice little algebra principle here where I could do 2 puts at 0.5 Q and 1 S. And that'll just double the cost. So I'll have 2 times 377. So 2 times 377, see what that is. So 754. And the nice part is that, okay, then that really is just either 2 puts on half of this stuff, or I could just call this 1 put on a full Q and 2 S's in a year. Super nice. So yeah, so we could do that. And now this is perfectly lined up. 1 Q with 1 Q, 2 S's with 2 S's. Ah, beautiful. Time is also the same. Now I've got 1 call, 1 put. I could do put call parity. So let me do that. So I've got here call 1 Q, 2 S, 1 year minus put 1 Q, 2 S, 1 year. Equals, okay, prepaid forward minus prepaid forward. Prepaid forward of the first thing minus prepaid forward of the second thing. So prepaid forward of 1Q minus prepaid forward of 2S. Okay, so nothing super groundbreaking right here, but yeah, awesome. Good, and then what are we even looking for, by the way? I guess we're looking for the continuously compounded risk-free rate of interest. So we're looking for R. So that's good. Now, none of that has shown up yet. So let's see what we got. But the call and the put, I know those prices, 543 and 754. And then, okay, prepaid forward on Q. What do we know about Q? Q was was a stock with continuous dividends. So the prepaid forward would be just be, oh, current price, but minus dividends, basically. So current price, 75, e to the negative 0.04, and for 1 year. Minus the prepaid forward of 2 shares of S. Okay, so that's nicely scalable. It's just going to be 2 times the prepaid forward of 1 share of S for each share of S, basically, right? And S was this diagram up top here. So that's this discrete dividend. So I'm going to again do current price minus dividends. So 40 minus that 295 e to the negative r. Well, times, let's just going back 4 months, so times 4/12. Or if you want to be super fancy, 1/3, but it's okay, perfect. But great, okay, so now I've got an equation. It's just really hard for the algebra, but that's okay. I've got the equation, I can just kind of solve for it now. So in fact, I probably won't even show the steps. We could probably do all this right on the calculator, right? So we've got this, this whole 5. So 543 minus 754. And then I'm just going to minus 75 e to the negative 0.04. Love this calculator, right? It's awesome. And then I'll divide by -2 to cancel out the -2. I'm going to subtract the 40. Right, just kind of peeling away layer by layer. And then I'm going to divide by negative 2.95. Okay, and I think so minus 40. Sorry, I think I might have messed up here. So, okay, so I get that minus 75 to the negative 4. So I got negative 74 divided by -2. So 37. Okay, 37. Oh, I think I actually multiplied by -2. Sorry about that. I don't know what's going on. So that minus the 40 divided by -295. Okay, 0.98826, and now log that, and then divide by -4/3. That's like 4/12. And I got here that R was equal to 0.0353. So what you got? You probably got it way quicker than I did. Sorry. That's what you get for being an old guy, I guess, huh? so 0.3539, whatever. Okay. But that was our risk-free rate. And yeah, it's just the algebra at the end. But the important thing here is when they say this word exchange, Jesse had a great idea. Why don't you just think of it as give? That's a great little simple substitution there. That's awesome. And then we just realized, yeah, we can just manipulate these things super easy. It's just a call can be written as a put can be written as a call. If it's a stock and strike, we don't usually do that, but 2 stocks, why not? And then any of these you could think of when you're trying to translate it into a call or put, you could use either a call or a put to do it. And then, yeah, put call parity can be used on anything. It could be any, two stocks, whatever. If you just remember prepaid forward the first thing minus prepaid forward the second thing, super easy. It's gonna be nice. Now, this also comes into play with arbitrage. They love to do put call parity and arbitrage questions. So that's what we're going to look at next. Because they say here, how can you exploit the arbitrage opportunities? Here's an arbitrage questions. We were able to kind of practice a little bit what we started last time. And yeah, let's see what we can do. So it says here, a stock has a current price of 50, pays a dividend of 2 per quarter. The next, which is to be paid in 3 months. So I'll kind of write that out here. So currently is 50, then 2 per quarter. Not sure how long this would be. Oh, it's a 1 year, so that's good. So I'll just stop there. Okay. And they said here, okay, it's paid through. Its current risk-free rate is 8% compounded quarterly. So I upper 4 equals 0.08. Nice. And they said a 1 year at the money call costs 312 and an at the money put costs 415. How can you exploit the arbitrage opportunity? All right, well, okay, I guess I'm not really sure what to do here, but they did give me a call and a put with the same strike. So totally that's put call parity. So let's see what that gives us. Call stock with the strike. I said it's at the money. So I guess that's 50 would be the strike here, right? Because that's the current price. So what at the money means for a year minus put stock 51 equals prepaid forward minus prepaid forward. So prepaid forward of the stock is just going to be 50 current price minus dividends. So 2A angle 4, and then minus the present value of K. So 50, I'm going to say V to the 4th, where V is for the quarterly rate. So J, and actually we know J is just 2%, right? It's just 0.08 over 4, easy. Okay, no problem. And all right, I guess I'm not sure what's wrong here. So let me just kind of put in the numbers that I know. And I guess I've got a 312 here, a 415 here. And the right side I can just compute all out. So let me just compute that all out there. So 50 minus 2 times fraction, 1 minus 1.02 to the negative 4 over 0.02, and then minus 50 over 1.02 to the 4th. I got negative 3.8077. All right, and then the left side, 312 minus 415, negative 103. All right, so clearly this is not equal. Okay, so so definitely something's wrong here. In fact, we see that the left side is actually bigger, isn't it? So what did we do? We've observed, we always write this, we observed that the call minus the put was actually larger than this whole thing on the right-hand side. Now for arbitrage with these, whenever you have like discrete dividends, you can kind of think of that dividend as like a bond or something, right? It's just a fixed dollar amount. So we're gonna kind of lump all this in as just one fixed dollar amount that we would need to kind of spend at time 0. So it's just going to be the stock, a full share of the stock now, minus then whatever all that was. And I kind of have all that left in my calculator here, so I guess I could just go back up and just remove that first 50. I mean, you could also subtract 50 from everything because it was added there anyways, but it was minus 53.8077. All right, now here's where we could do what we did last time. We can think about, well, there's the 2 different ways to do it. You can move everything to the greater than sign or to the less than sign, just as long as you remember what you're doing and why. So like a lot of the programs, they say to move it over to the greater than sign, and then it becomes a cash flow thing. I think, and feel free to do that if you want, I think that kind of makes it just one level harder. So I'm going to move it over to the less than sign. I'm going to let the arrow point the way. And that's going to tell me my portfolio right away. Negative call plus put plus S minus 5381. And so then that's super nice because I know I'm just going to have a short call, long put, long stock, and then minus bond. Okay, so long is lend, short is borrow. So I guess I'm going to borrow 53.81 to do it. Okay, and that's it. So I would write the call, purchase the put, purchase the stock, borrow 53.81 to do it, and that will exploit the arbitrage opportunity for me. And feel free doing it the cash flow way too. There you would move everything to the greater than sign, and they'd say everything would just be negative of this, but you'd think in terms of cash flows, but you'd end up with the exact same final result. I just think this just gets you there one step faster. Okay, but good. All right. Any questions about that? Super nice, right? Actually, like pretty doable. It made this problem like rip through it. Now, the interesting thing is like we don't really know what's not priced right here. It could be a bunch of things not priced right, or it could just be maybe just the call, maybe just the put. So notice how you don't really even know that, but you can still do the arbitrage and you can take advantage of all the mispricings all at once if there are some. Okay. All right, let's look at now currency options, because this is probably one of the biggest things I have questions about is doing things with currencies. And even, question here, first of all, was, do you borrow 53.81 or is that the present value of that? Good question. So by the way, the put call parity itself is already a time zero equation. It's already present value. So this whole equation here is already present value. And that's actually going to come into play for one question we're going to have in another seminar. So, and it kind of makes sense because everything's like, oh, prepaid forward, like current price of call, current price of put. The put call parity is the time zero equation. So this is actually portfolio. This is actually what we do right now. So we don't have to move this around like 2 times 0. It already is at time 0. So yeah, great question. Okay. And then we have another question here too about, do we always go back to the put call parity question to find our arbitrage portfolio? Okay, so it depends on, you're not always going to go back to put call parity for every arbitrage question. I'm going to hopefully give you a few different examples of that in this seminar and in ones to come. But yeah, it'll all depend on the situation and what they want you to use to exploit the arbitrage opportunities. So you'll see that in some cases you'll use stocks and bonds like we did in the other one. That wasn't put call parity. This one, just because they gave us a call and put on the same price, we're kind of like, think like, oh, maybe that's the constraint, that formula, that equation was the thing that was violated somehow. So in this case, we would use that just because that's the sort of things they're telling us about in this question. But we'll see actually later today, we've got a couple other arbitrage questions where we're going to use other things, other constraints that are violated. Yeah, but great question. And it is just, it is a little bit, sometimes they're not very good about the questions. They just say like, oh, how do you exploit the arbitrage opportunity? And there might actually be a ton of different ways. They really should be a little bit more clear, like, oh, how can you use, shares of stock and, bonds in order to exploit this arbitrage opportunity, because there may be more than one way to do it. So, but usually you kind of look at the answers and see what they're looking for. You're like, oh, okay, I guess I'm going to need to know, oh, calls, puts, stock, bond. Okay, that's all put call parity stuff. So kind of gives you a clue as to what you might want to use. So yeah, excellent question though. Thanks so much for that question too. Good, okay, so now currencies. Okay, so I'll show you how I do these. The thing I don't like about the books and the study resources is they kind of just tell you some formulas and you're like, oh, okay, just use these formulas and you got it. But I don't know, there's like way too many things that could be flipped, or like maybe they could say call, but you think put or whatever. And it's like, there's just a lot of things that could go wrong with some of these questions. So I wanted to do one where I'll show you how I think through it, how I work on it. And to me, always the key to success is keeping track of what currency whatever you're dealing with is in, whether it's the whole equation or just part of an equation, but just keeping sort of in the back of your mind, as long as I know what currency this is that they're talking about, domestic or foreign, I'm good. Okay, and then I kind of try to stay away from the formulas and I try to stick to just the principles. So I'll show you what I mean here. So let's just think of us that, let's say we are in Japan and our currency is, yen, but then we're interested in investing in stuff with the US. So our domestic would be the yen, and we're trying to, do business with the States. But here's where it comes to something like in this exam, because from our point of view in Japan, the US currency is kind of like fluctuating all the time, kind of like a stock, right? It's sort of like randomly goes up and down, and like compared to our money, it just sort of like, it's random. It's kind of unknown, and its value in a year or 2 years is also going to be unknown. So from our point of view, their currency is like a stock, basically. So that's what's going to happen. The big thing is we just need to keep in mind, what currency are we really dealing with? So for us, whatever the domestic currency is, that's going to be sort of our main frame of reference. But within a problem, that can actually shift around. And so we'll see that example here coming up. But in order to keep that straight, to keep that sort of in our mind, I'll use a little subscript, and you might even see this in some of your resources too. They'll use a subscript just to show you which currency you're kind of dealing with. What's the domestic? So here, we're going to say that the yen is the domestic currency. And for me, I'm just going to do the Y. I'm not going to do the Y with the 2 lines through it. And again, however you're okay with that. If you would prefer it with the lines and you feel better about it, great, feel free. Just sometimes it gets a little messy for me. So, but for me anyway, so I will subscript it with the domestic currency, but mainly because that's going to tell me that my answer is actually going to be something yens. This call is, they would call it yen denominated, because it's going to be denominated or expressed in yen dollars, because that's my money. That's my currency, my domestic currency. So this yen means your answer is in yen. Okay. And that means this call, if they give you like, 2.5, it's 2.5 what's? 2.5 yens. Okay. All right. Now, because of that, usually we have a call would be on like the stock and the strike. So for us, we know for sure the stock, that is, we know for sure the strike. The strike, if it's $100, we know exactly what that means for us. But if we say the stock, that's the thing that sort of like fluctuates. So for us, we're always going to see that it's going to be whatever our domestic currency is here, it's going to kind of alternate now. And this will be dollars and then yens. And in fact, we're going to have usually $1, kind of like corresponding to 1 share of stock. And they're going to have some sort of strike, some K yens here. Okay, so we'll say K yens. So that's not K times Y, that's the only weird thing, but as long as you kind of know what it is, that's fine. It'll usually be a number, so it won't be weird, but we're gonna have that, yeah. So this yens here, that's not times, it's just the currency placeholder for us. Okay, and then the put, same thing, it would just be put, a yen denominated put on dollars, just like a call on a stock, right? In dollars with K yens as the strike. Okay. So then the put call duality here, a call equals a put. So if I had calls in yens, $1 and K yens. All right, well, I'm gonna show you what happens here. Well, if I did the put call duality, then it would still stay yen denominated because it's still in terms of yens, but I would just switch those two. So now I'd have K yens and $1. Now that feels a little bit weird because these should always alternate. So domestic, foreign, domestic, it should always look like that. And usually it's this first parameter is just a 1 because it's usually like a 1 share of stock, right? And it doesn't have to be, but usually it is. So we're going to fix those two things. We're going to fix that it should be really denominated in, well, it should be denominated in a way that allows us to alternate. So I really kind of want it to be dollar denominated. So there goes dollars, yens, dollars, right? So we would kind of be shifting our point of view to somebody from the States, but that's fine. We can totally do that. And the other thing is that I really need this to be 1 yens and not K. So that's actually the easiest one to fix. So that's what we're going to do, kind of like we did before. I can scale these things real nicely. If I just had 2 calls on 1 stock, that's just like 1 call on two stock. So I'm actually going to kind of like factor out the K in a way. So I'm just going to have now, like, instead of having one put on K yens, it's K puts on 1 yen. But I'm just going to, I guess I'm dividing a K then into each of these here. So I'm going to have 1 over K dollars. And now here, the thing that just gets a little bit weird, but I need to change this to a put in dollars now. So I'm going to kind of change this. Okay, and I'm going to have K of those. And now my big thing is I just need to know, okay, if I have a dollar equals, 100 yens, am I going to multiply this by 1 over 100 or 100 over 1? That's the big question. So maybe I can get your thoughts on it. Maybe you can use the reaction things here. And maybe for the yes, do you think it's 1 over 100? That'll be yes. And 100 over 1 would be no. maybe just think about what you think it would be. But which one are we going to multiply this by? Because we do need to like kind of handle the fact that we just changed from yens to dollars. So we're going to have to convert it somehow using the current conversion rate. So we do need to do that. So maybe put your vote in now and we'll kind of see. And I probably won't remember who said what anyway. So, but go ahead and like, yeah, maybe, what do you think? Do you think a 1 over 100 or 100 over 1? So let's see. Yeah, it's a little bit mixed right now, huh? All right, let's see here. So I think we got kind of half and half here. So, all right. So the thing is here, the left-hand side, what is that in, yens or dollars? And the answer is it's in yens. But currently this put over here, that is now converted into dollars. So over here, I need to get rid of the dollars to put it back in terms of yens, because ultimately my left-hand side, my answer has to be yens, right? So so what I'm going to have to do is I'm going to actually have to divide by the dollars and put in the yens. Okay, because I changed this put now into a dollar denominated, so that answer is going to be dollars, but I need to remove it and make it yens again. So I guess I'm going to have 100 yens over $1. That's what I would need there. So, but again, the whole thing was just kind of keeping track of it. So that's nice. Okay. So, okay, what about now these prepaid forwards again, if these are for prepaid forwards on currencies? Well, this is kind of what we did before, but now we're looking at from a different point of view. So now if I'm in Japan, the yen is my current rate. So if I wanted to do the prepaid forward on the dollar, that's fine. I'm still going to take $1 and I'm going to discount it by its rate, dollars times time. But because it's actually I'm in Japan, I now have to convert it to my money. And so I'm going to divide by the dollars and put in yens. So I'm going to have 100 over 1. And that's going to kind of allow me to keep my prepaid forward in my money. So in yens, it's going to look like that. But if I had the prepaid forward of 1 yen, it's already in my money. So I'm just going to discount it by its rate. So 1 yen, e to the negative r yen times time. Okay. But there I don't need to convert anymore. So this is really like not really needed anymore, but that's fine. I'll just kind of put it there. But just realize as we put these, it's more just for us to keep track of it versus trying to memorize a formula and stuff. And the reason why I think that's so important to think of it this way is because sometimes they're like, oh, the current exchange rate is, 1 over 100 or even 100 over 1, depending on what perspective they're looking at. But like, how do you know that you're going to use, like, that's what they call this. They have like probably the formula K times X times, the other thing. And I'm like, well, they could have easily given you either one. So how do you know which one? Are you going to do X or 1 over X, 0, or whatever? Like, which one do you do? So that's why I feel like I don't even use this at all. I just think about the situation here. I kind of like think through, I don't think of the formula. I just think of sort of like the process. Okay. So the cool part is here, put call parity still works if it's a yen denominated, $1 K yens, a put yen denominated $1 K yens. Then it's actually just going to be prepaid forward to the first thing minus prepaid forward to the second. So prepaid forward of $1 minus prepaid forward on K yens. So super nice. And then I just have to keep in mind, well, what denomination is this equation supposed to be in? And well, we see, yeah, left-hand side is totally yens. So the right-hand side would have to be totally yens too, or I could do dollars and convert if I want, that's fine. But that's where I get back to this whole like, okay, this $1, I'm going to do the dollars discounted by its rate. But it needs to be in yen, so that's where I'm going to have to convert it to yens. And then the prepaid forward on K yens, well, that's going to be K, prepaid forwards on each yen, but that's great. It's already in yens, so I'm not even going to worry about it. So we got something like that, right? But it's not so bad as long as you realize that, yeah, the currency is just the thing that can kind of muck it up a little bit. You just have to be a little careful about that. Just keep track of it. If you have to write it in there like I'm going to do, just feel free to do it. No problem. And thanks for playing, by the way. Thanks for like voting and giving me your thoughts on stuff. So it really helps. Thank you so much. Okay. Oh, and then we have a question here too. So having a hard time understanding how $1 as the stock price and K yen represents the put. Oh, the put strike price. So the K yens will be the strike, and the $1 is like the stock. And the way that we can kind of think of it, we don't have to really think of it like a stock if you don't want, but we just think of it like, well, whatever our currency is, we know what that's going to do. Like if I have $100, I've got $100. But every other currency, if you kind of like look in the market and you say like, oh, you want to find out how much your money is going to convert to there, it changes every day, right? It's almost like a stock price where it goes up sometimes, it goes down sometimes, and it's just everywhere. So for you, the foreign rate is just unknowable, kind of like a stock price is like unknowable. So that's the risky asset, is some foreign rate. So for us in this example, our main currency would be yen. So any other currency would be unknown. It would be kind of like a stock, like we have here. So that's why it sort of makes sense to put it in that first slot. Okay, for us, we don't have to really think of it too much like that, but we kind of want to think of the thing that's going to help us with problems the most is that the natural thing that we typically see with these options is it usually goes whatever the denomination for the currency is, and then it should be the other one, and then back to the original. The denominations are important, so it usually sort of like alternates as you go. And that can help solve a lot of problems. It doesn't have to, but it usually is like, it's usually set up that way. So that's kind of the big thing to remember. And it just behaves like a stock because its value is not known for us, And part of it is just like, yeah, we're just trying to eliminate some of the overhead. Some of this oh, okay, well, if you're in this currency, you think of that currency, and then you kind of like, oh, your dollars to that. And it's just like, it becomes so much to think about. We're trying to streamline the process a little bit. So hopefully that helps. So we're going to have an opportunity actually twice in the seminar series, once here and then once I think maybe on the last day or something. But here they won't tell us call or put. And I don't know about you, but I struggle with that like so much. So here they're like, oh, okay, just determine the cost of the options that the company has to purchase. So our responsibility will be to determine, do we want to call or do we want to put? And then what's the parameters? And to me, that's actually not an easy thing to do, but I've got two methods that I think might help. So we'll try it here, and then we'll be able to try it again one more time later. So, all right, but let's go ahead and look at this this question here. So a Japanese company has a second facility in Thailand. So I tried to use like two non-US countries just for us so that we can practice this idea of like, let's sort of put our frame of mind in one thing and then try to think of another thing as like the foreign one to us. Okay. But where kind of both of them are foreign to us in a way. So, all right. So they would like to expand their Thailand facilities in a year, and their projected expenses are 100 million Thai bahts. However, they would like to guarantee that they'll not pay more than 320 million yens to accomplish it. Currently, each bot exchanges for 3 yens. Okay, so probably right now, this is like information overload, which is fine. But basically, we realize we're doing some sort of exchange between like yens and bahts, Thailand to Japan. Not really sure exactly calls or puts or whatever, but that's okay. We've got this, and we know we'd kind of want to exchange, you know, these two. So between the 100 million Thai bahts and 320 million yens. Probably what I'll do is I'll just sort of cut out some zeros just to keep things simple, which you should probably do too. All right, but at any rate, so worried about adverse effects of the exchange rate, they purchase appropriate options. If the current continuously compounded rates of interest for the baht and yen are 3% and 5%, so okay, our baht is 0.03, our yen is 0.04. Okay, we can put that down, no problem. Oh, and then back up here too, we could say each baht exchanges for 3 yen, so 1 baht equals 3 yens. That's currently what happens. Okay. And okay, a 1-year baht denominated call on yen with strike. Oh my goodness, cost. Oh my goodness. Okay, determine the cost in yen of the options the company must purchase. Okay, all right. Well, let's do that sort of second to last statement there. It says here a 1-year baht denominated call on yen with strike 3.3125 costs 0.23. Oh, okay. All right. Let's see if we can peel this apart. So it's a baht denominated call. Oh, that's easy. Call denominated in baht. And it's on yen. So for 1 yen, and I should have some sort of baht here. So baht, yen, baht in this case. Okay, and it's a 1 year, so that's good. The strike is 0.3125, so that's good. 3125 bahts. And they said it costs, so equals 0.023, and 0.023 what's? Bahts or yens? So maybe we'll say, maybe throughout this problem, we will say, oh, okay, well, actually, we probably won't ask this too much, but what do you think? Baht for yes, oh, sorry, baht for no, and yen for yes. So what do you think it is? Is this bahts or yens here? What do you think it's going to be? Good, excellent. B's, perfect, good job, right? And just because that's what it means to be denominated in it, awesome, great job. Good, so it's just denominated in bahts. So even though they didn't say bahts, that's what they mean. Perfect. Good, okay, now they said determine the cost in yen of the options that you're gonna need. Okay, so now we're gonna need some sort of option, call or put. They didn't tell me which, but they want it in yen. So they want it denominated in yen. So that's nice because I guess I know that it's going to have to be bahts and yens here. So that's cool. So I don't really know exactly what's happening. Usually it's 1 bahts for so many yens. But I guess here we know that we're really doing 100 million bahts for 320 million yens. That's kind of the option that I'd want to sort of exchange here. So I'm actually going to put 100 bahts for 320 yens. And I'm really talking about millions. And if I ever sort of change something in a problem, sometimes I'll write in the bottom right corner, I'll put a little like, for my answer, I really want to multiply everything by 1,000,000. Just as like kind of a little reminder to myself here, like, oh, I scaled everything by 1,000,000. Probably you won't get confused by the answers, but that's okay. Maybe just like a little note if you ever have to do that. You just put that in the bottom corner, just as a test taking strategy. But so the big question is, do we want this as a call or a put? So, all right, so why don't we vote now? So let's say call for yes, put for no, let's say. So what do you think this one's going to be, a call on yen or a put on yen? What do you think it's going to be? And for me, this was always the hardest thing. I would always get this wrong. So I sort of developed, like, I developed one way to think about it, but then I had another student that had this like super simple way of doing it. And I was just like, oh, you're way smarter than me. So, all right, so let's see what we think. So is it a call or a put in yen? So, all right. Okay, good. So some voted here. All right. So here's what the way that I thought about it originally was I kind of thought about, what am I worried about? So what am I really worried about here in this case? Am I worried that because I'm buying the second, I'm trying to have the second facility. Their expenses are 100 million Thai baht. I'm in Japan, so I know that I'm going to have this 320 million yens, but I'm not really sure about what this 100 baht's going to do. What am I worried about? Am I worried that the 100 million baht is going to be more than the 320 million yen, or less than? What am I really worried about? And I guess for me, I know I'm going to have the 320 million, but I'm worried that the 100 million baht is going to be worth more than that. Like, I won't be able to exchange it. I'm worried that it's going to be greater than the 320 million yen that I currently have. That's what I'm worried about. Because I'm definitely going to have that, but when I go to exchange it, what if this is worth more than that? Then but if I only have 320 million yens, I'm not going to be able to exchange it for enough money. So I kind of think of this as like, well, what am I worried about? Because then that kind of helps me, because then, well, this is sort of like the stock in this case, and I'm worried that the stock is going to be more than the strike. So what kind of option is going to pay me if the stock goes more than the strike? It's a call. So this thing here is a call. The option that I need is a call. Okay. Now the other way to think about it is actually so simple. It's like it calls an option to buy and it puts an option to sell. And we can think of this as like, okay, if I'm in Japan with $320 million, what am I trying to do with these yens, or these bahts? Am I trying to buy them, or am I trying to sell them? And I guess in this case, I would like to buy them at some point in the future. So that was what my student said. And I'm like, man, that is like genius. You're like super smart. But it is. So really, I've got the 320 million yens, and I would like to buy 100 million bahts later. So I would need an option to buy, which is a call. So just another way to reason on it. Pick whichever way you like better, but usually it's pretty clear. Are they buying these or are they selling them? Like, if you have some sort of investment and you're trying to, you're going to try to convert back into your money and you're trying to sell it later, well, then that would be an option to sell. So that would be like a put. Okay, but just, yeah, for whatever, I hope this helps a little bit, but that's kind of how I sort of reason on it. I couldn't reason on it any other way. I thought of this, but whichever way you like better with the student set, or this way, whichever, just kind of, as long as you find something that kind of helps work for you, that's the best. Okay, but now that we have this, all right, I'm looking for this call. Now I need to know, how do I actually get there? So I do need my answers in yens. That's fine. And it is in terms of the 100 bahts for 320 yens. So if you wanted, you could actually kind of pull out the 100 if you want, but I don't think we really need to do that. We'll be able to keep it all in here like this. But so the thing is, I don't really know a lot. I just know this. That's the only thing that I have. So I've got to kind of relate things back to that somehow. But for that, I realized that I'm going to have to switch bahts with yens, because this one's yens and bahts and not bahts and yens. I'm going to have to switch the currency because it's currently yens, but I want it to be bahts. So I've got kind of a lot of things to do, but that sort of sounds like what we just did with the put call duality. So I'm going to kind of head in that direction, and I'm going to say here, well, let's first call this a put now in yens. And I'm just going to switch the parameters. 320 yens for 100 bahts. Right, that's all I'm doing. Just the put call duality, super simple. It's still yens. That didn't change. Time didn't change. Just the two parameters changed, no problem. And then I just want to make sure that I get the right scale here. So 100, I really want 1 yens, but right now it's 320. So I think I'm going to divide inside. I'm going to pull out the 320, basically. Divide the inside by 320, multiply the outside. So I'm going to have 320 puts on yen, each with 1 yen, and then 100 over 320. 0.3125. Ah, that's nice. At least we feel like we're on the right track. So that matched with that perfectly. Awesome. If it didn't, we wouldn't be able to do the problems. So we feel like, okay, I feel like I'm on the right direction. So that's good. Okay. So now what do we do from here? Okay. So now the only thing is I really need to change this. Well, a call to a put, so I need to fix that. But also I've got bot and yen, I need to fix that. So I'll do these. I mean, we could do these in any order. Maybe I'll just, maybe I'll change this to a put in bots first. So this is gonna be 320 put bot, 1 yen, 0.3125 bot, and 1. Okay, so that's no problem. And now I just have to remember, well, what do I need to multiply by? I do need to change it. So we think back and we're like, oh, okay, this is all time 0, by the way. So we've got, so I've got here, the left-hand side is in yens, but currently this is in bots. So I'm gonna need to kind of get rid of the bots and put in yen so that it stays consistent with the left side. So I'll need to divide by bots and divide by bots, multiply by yens. That way it kind of keeps it consistent. So I've got here, my current rate is 1 bot for 3 yen. So 1 bot, 3 yens. Okay, awesome. And now this part here, this put in bot, that's going to be compatible with this call in bot because I can do put call parity now on that thing. Because those are all, they have the same parameters, they're in the same denomination. Awesome, we can use put call parity. And in fact, I've got, so I'm going to sort of do that on the side a little bit here. Call on bots minus put in bots equals, okay, prepaid forward of the first thing. So prepaid forward of 1 yen. So prepaid forward of 1 yen, but the left-hand side's in bot. So this is going to be one where I'm going to have to convert back to bot in this one. So I'm going to have 1 yen, but back with its rate. So negative 0.04 for 1 year. So that's good. But I'm going to have to keep it consistent with the left side of its put call parity, which is in bots in this case. So notice how it sort of switched in the problem, but it's just because this thing here itself is in bot, and this is where we just need to keep track of it. And this is the part of the battle, right? So as long as we keep that in mind, it's okay. They just switched here. We just now have to think in terms of bots, but that's okay. That's just what it is. So I'm gonna have to get rid of the yens, put in the bots, and here I've got 3 yens and 1 bot, no problem. Minus the prepaid forward of the second thing, so that's 0.3125, and then bots back when it's in bots, so that's cool. 3125 e to the negative the bot rate, which is 3%. Can you see that? Sorry. E to the negative 0.03. But that's nice because if I'm solving for, I want to substitute in for put, so I'm going to put that over there, and then I'll move those two to the other side. So this becomes 320 times 3 over 1 times, okay, the call, which is 023 minus this term, 1/3 e negative 0.04, and then plus 3125 e negative 0.03. All right, as long as I got the currencies all set, that's fine. As long as I know what the rates are, great, totally fine. Okay, and so yeah, crunch this out, and this is our answer. And then we had a question here to change from yen to bot. Wouldn't you divide by yen and multiply by bot? Okay, so it gets back to this thing, right? So are we changing from yens to bots or bots to yens? So in this case, we have bot, but we'd like yen. So I think we're actually going from bots to yens, not yen to bot in that case, if that's the one you're talking about. But yeah, it's good. So yeah, let's find out what this is here. So 320 times 3 times parentheses 0.023 minus 1/3 e to the negative 0.04 plus 0.3125 e to the negative 0.03. So I got 5.761. Oops, 761 ... And again, that would be yens. So yens, but we actually wanted millions. So I guess we want 5,761,039.5 yens. So obviously their answers probably won't be that crazy, but that's all right. Won't be that specific. Okay, and then we have another question here too. Okay, so is it implied that the strike indicated in the problem is 0.3125 is the denominated currency bot? Yes, it is actually. So here they didn't say the strike was, the strike was bots, but it's implied that it has to be bot because it's a bot denominated call on yen. So on yen means the stock basically is yen. The strike would have to be bot. Yeah, good. So if they said it was yen, would we have to convert to bot? And yeah, so it's true. Good. So good job. If they said it was yen, we would have to kind of find out how many bot that would be. Good. Because it would have to be that. And sometimes they do that in a problem. They will sort of give it to you in kind of a weird way. I feel like that would be more advanced, but I haven't seen a ton of those, but I feel like they very well could, especially on the test. They love to do that. Okay, and then another one here. So I feel like to get the answer from call yen to put yen, put call duality, you have to know that this is the algorithm solution, or is it just me? Okay, so to go from calling yen to putting yen. Oh, okay, so how do we know that this is the way to solve this one? Is that maybe kind of the question? Okay, yeah, no problem, I get you. So yeah, well, it depends, right? Because sometimes like later when we talk about black shoals, they won't give us this, but they'll give us like the volatility, right? And in that case, we'll be able to just actually compute this out straight from black shoals, because it's also kind of like, it's also the same thing. It's just kind of a more general black shoals formula. Okay, but in this case, because they gave us this information about some other option, we know that we're going to have to use that option somehow to be able to find it. And so, yeah, we have to kind of like think back to, well, what do we have and how can we possibly use that to be able to solve for what we want to get? So you're right. In this particular situation, yeah, we're actually going to need to do the duality, go call to put, and then sort of try to fit that with the parameters. And the other way that you could have done it, by the way, is you could have actually done all of this work on this thing. You'd still have to do basically the same stuff, and might be a good exercise to do if you want to try it. Maybe like, okay, so if I had that as my starting point, and then maybe try to convert that somehow into this one. Because you're like, well, okay, my goal would be this, so I would have to like, scale everything by, I guess, 320 to get the right numbers. And like, you could kind of go about it that way. I feel like this way is the simplest, but maybe, I don't know, just to kind of practice or whatever, you could probably do that. And maybe even try in some of these, maybe do the steps in a different order and see if you can get that too. Yeah. The only problem I thought with using this first and then kind of converting that or something, I felt like sometimes that's a little like more awkward. It felt like to me. So I kind of always like, well, what am I after? And then work at it that way. But probably if you use this as your starting point, you'd say, oh, 0.023 bots equals, and then the call, which equals the put, which equals, and then you kind of keep going from there. But I feel like that might be a little bit less natural maybe. Okay, but yeah, try it both ways and see if you can do it. Try to using the principles that we did in a different way. That'd be great. Okay. All right, well, how about we take just a couple minute break here. We'll come back in a few minutes and then we'll finish off here. We're going to talk about some kind of totally different topics now as we move on. So yeah, so let's take a few and we'll come on back. So any questions about that last one here? Now that you had a chance for it to settle. Anything that you were thinking of it? Because it is a super, it's not really like a hard problem. I mean, it is just keeping everything straight. But any questions, big or small, about that one? Please don't feel like you're stupid or anything like that. That's definitely not the case. But they're just like really, it's just like tedious keeping track of the currencies. So if you have any questions, please feel free to to ask, no problem. Okay, sounds good. All right, so then, all right, well, let's keep going then, and let's talk about now option bounds. So that's kind of like the other half of this seminar here was about option bounds. We're going to see a bunch of, there's actually a few arbitrage questions relating these. And some of them I won't give total reasons for them, but we'll be able to have sort of like a good thing to think about to remember them. So the first one here is just the kind of like the max and min option bounds here for these. So first of all, we always know that a European will cost less than an American or equal to for puts and calls. And anybody have a good reason for knowing that, why that's the case? Because part of this will be like, well, we kind of want to think like what's more valuable to us, or like maybe kind of what's going to pay more or something like that. Those are all kind of ways that we can see which one should be worth more. We could also think about like present value of payoffs and stuff like that. So yeah, okay, well, we got a lot of good things here. So yeah, basically the basic idea is that you have a lot more flexibility with an American option. And with that comes options for you, no pun intended, I guess, right? So with that comes power, because you can exercise an American anytime you want, but a European, you have to have discipline to go all the way to the end. And so because the American has more options, it's more valuable to you. And so it's going to be more valuable anyway. So good, excellent, great. Thank you for your thoughts on those. Great, thanks guys, appreciate that. All right, so that's why Europeans will always be worth less than American ones. And there's going to be kind of like a nice pattern we're going to notice here about the bounds for American ones and the bounds for Europeans. In fact, American option bounds are going to look a little nicer, but European ones are going to be almost the same thing, except sort of like as if we did that at the end and brought it back. So it's going to be kind of like the present value almost kind of situation as to what we do for the American. So so the main bounds we'll start with the American ones always here, and then we'll kind of get the European ones based off of that. So the American ones are going to be where we can think about like what would be kind of what if we did it right now, because an American option allows you to do it right now. So we can think, well, what should an American option, what's the most it could ever be worth? And the answer is that it could never be worth more than the stock that it's over, right? that it uses. I mean, if it was worth more than the stock, and it's just an option on the stock, wouldn't I just buy the stock anyway? Why would I buy the call to exercise to pay K to get the stock? Wouldn't I just buy the stock? Right. So that's kind of the idea there. And then the lower bound would be basically as if I exercised it right now. So it's actually going to be here S0 minus K. Okay. And that kind of makes sense too. If it wasn't even worth exercising right now, then wouldn't you just do that? So okay, but then what about the European ones? Well, so the nice thing is the European ones are like, oh, what if I did this later? It'd be worth the stock price then. And then like if I were to exercise it then, but then I want to bring it back. So actually this will be sort of like the prepaid forward of the stock here. And this would be prepaid forward on the stock minus, well, present value of the prepaid forward on K, but present value of K, I think is kind of what they like to say better. So present value of K. And actually those are the bounds. And so it works out pretty good. But then you also get some weird stuff if you try to like, well, put this in there too, because then you actually have like, this would be less than S0, or, you can kind of like connect these two a little bit. So it's just not so clear, but I feel like if you remember these three, that should be, that should be good enough. And a put will be basically the same thing, but just sort of flipped around. So we actually know that the put will be less than if I were to get the maximum amount now, which would be K. And it would be worth at least as much as if I were to exercise it. So K minus S. And then the bounds here would be sort of like the present values of those. So present value of K. and present value of K minus prepaid forward of the stock. Okay. So it has some nice symmetry to it. It's not too bad to remember, but sometimes you can use these to be able to do like arbitrage questions, or they might ask these on, might need to know these for a question. Okay. All right, so for example, let's do an arbitrage question based off of these bounds, and kind of goes back to that question. All right, how do we know what we're going to need to use for arbitrage? Well, sometimes they're not very good, but they don't really give you a lot of information either. So maybe you could just use only the things that you can kind of think of at the time that would relate the information that they give us. So we're going to see here, they actually don't give us a lot of information at all. So let's see what we can do here. So this is here, in the market, there's a 1-year 90 strike European put on the stock for $7. Okay, the stock has a current price of 80. So, okay, so it's European, 1 year, got it, okay. The stock has a current price at 80 and pays a dividend of 3 and 6 months. Okay, so I'm just going to kind of draw that situation out now. So it's currently 80. In 3 months, it's going to pay a dividend of, 6 months. 6 months, it pays a dividend of 3. And I know I'm dealing with a year here. So if the current interest rate is 5% continuous, show how to exploit the arbitrage opportunity. Okay, well, basically they only told us something about the stock and the put. They didn't say anything about a call. They didn't say anything about anything else. So, all right, I guess we have to kind of think of like, well, what relationships do we know about basically a put and like current stock price or whatever. So that's why we think like, all right, I guess I should probably think back to what are some of the most basic bounds I know about a put. And I know that a put should always be, well, if it's a European put, it should be less than the present value of K. And what was the K in this case? It was 90. Or if I were to exercise it right, if I were to exercise it, so max of 0 and K minus S, but I'd have to do the present value because it's that times 0. So present value of K minus prepaid forward of the stock. Okay, so I just look at like evidently something on here is going to get violated here. So I know that the price is 7. I'm pretty sure this bound's pretty safe. The present value of 90, unless I've got some like super crazy interest rate, but probably that bound's okay. But we can compute it out. But I don't think we really need to, because I don't think that's the problem. Over here, this is probably the problem. Maybe that's just not, maybe that's too big. The price would actually be too small. So let's just compute it out. So present value of 90. So I've got 5%, so 90 e to the negative 0.05 minus, and then prepaid forward on S. So S is 80 minus 3e to the negative 0.05 over 2. That would be a half a year's worth of interest there, right? So, all right, let's compute out the left side. 90 e negative 0.05 minus parentheses 80 minus e to the negative 0.05 over 2. Sure enough. So the bottom bound there is actually 854, well, 8.53, 6 something. So 54 is fine, it's no problem. But that should really be, the put should really be priced higher. Okay. So, all right, what do we observe? Well, we observed that actually this stuff was larger than the put. And again, for this, well, any actual dollar amounts we'll put in as kind of all wrap it up into a bond, but the stock will just kind of keep it as a stock. So here we're going to have 90 e to the negative 0.05 minus stock minus 3e to the negative 0.05 over 2. And we're going to kind of wrap everything all up here. Any dollar amount is kind of like a bond. Any other items like calls or puts, we just keep as calls or puts or stocks or forwards or whatever. So this over here is minus S and then plus, so 90 e to the negative 0.05 plus 3 e to the negative 0.05 over 2. and I got 88.54 greater than the put. All right, and then is this a time zero thing or a time t thing? And we see, oh yes, this is time zero, so we're good because it is current price of the put. So we are actually dealing with a time zero thing now. So then arbitrage always comes back to the same thing. We want to say like, all right, what we either do the cash flow method or the portfolio method. Either one is good. I'll do portfolio just because it gets us there quicker. I'm going to move everything to the less than side. And that's going to be my portfolio. Portfolio is plus P plus S minus 88.54. So I guess I would purchase the put in stock and then long is lend. So borrow. So I guess I'm going to borrow 88.54 to do it. So buy, put, and stock, borrow 88.54. Kind of makes sense that you're going to borrow a bunch of money if you're going to buy both of these things. So it kind of makes sense. So actually super good. And if we did the cash flow method, obviously we just move everything to the other side. It would be negative, what we see here, but then we do reason on it in terms of cash flows, but we get to the same final ending point. So, so whichever way you want to do it, I just think this just gets us there quicker. But yeah, if you kind of like don't want to sort of change up your your system at this point, totally understand that. Okay. Any question about that? Not too bad, right? So hopefully, like the arbitrage, you're getting a little bit more comfortable with them in a way. So I have a hard time reasoning on it personally about like, oh, this thing's overpriced, so you want to do this, do that, like buy this one, sell that one, and kind of like, I feel like when I tried doing that, I'd always get it wrong for some reason. But sometimes, yeah, so sometimes it just like, yeah, it gives us trouble. Okay. Oh, and then, yeah, good question here. How many stocks do you buy? You know, I actually never thought about that. I haven't seen that be an issue in the question, but I think actually probably like you, I think maybe you would actually buy the like e to the negative delta shares of stock. Yeah, I think that's, yeah, good thought. But in this case, I feel like a lot of times with these though, if it had dividends, that would already show up. And in fact, this one had discrete dividends, didn't it? So in this case, it had discrete dividends, so you wouldn't have to worry about e to the negative delta t. You wouldn't have to worry about that. But if it actually, okay, so I think the answer is that actually would just be one share of stock, specifically because there were discrete dividends. If it had continuous dividends, interestingly, that would actually already come out. It would actually be told for you on this question. It's super cool because if I would have done the prepaid forward, I actually would have had current price e to the negative delta whatever, but that would actually have been in my, that would have been in my equation here, s e to the negative delta t. So then it would have already told me that instead of wrapping the discrete dividend into the $90, it kind of, the dividends would be actually included with the number of shares of stock. So it would actually kind of show up in there. So yeah, great. The 88.54 includes those dividends. So great. Yeah, good. Excellent. Yeah, and that's per put for sure. Yeah, good. Okay. Oh, good. Yeah, excellent. Yeah, great question. Thanks. Yeah, didn't even think about that, but good one. You got it. Okay, and then just a couple more bounds I just wanted to talk about here. So there are, in a way, it's easier to deal with puts than it is with calls, at least for some of these bounds that we're going to be talking about here. Okay, so I do the puts first and then the calls. But for me, it helps to kind of think of this graph. So this graph actually is the graph of strike versus price. So it's not the price for the put or something like as if this was like current stock price or future stock price or something like that. That's different. But if you just think about it in terms of strike, we actually should think about this thing here. And it kind of makes sense that if the strike was 0, the put would be worth 0, right? Because the put's only going to pay if the stock goes below the strike. So we think of like, oh yeah, I guess the put one would have to start at 0. The only thing it can do is go up from there. And it's interesting that it goes up, it's concave up, so it's going to be bendy up. And it's interesting that there's sort of like a limiting slope here. And the slope is actually, the limiting slope would be a 1. Well, it'd be a 1 for American options, but it would be the present value of 1 for European options. And maybe we'll talk about that a little bit. But so 1 for Americans and present value of 1 for Europeans. And we're going to see this like, oh, okay, if we think of American ones first, it's going to be a little cleaner. And then the European ones will just be sort of like a present value thing kind of deal. All right, but if I think of this, I can actually get these bounds super easy because, well, one thing I can do is think of like, well, it's actually increasing each of these. So if I have K1 and K2, then I know that the price for K2 would actually be more than or equal to the price for K1. But that's just the fact that it's increasing. It's just going up. That's all it is. So the higher the strike, the higher the price. Now you might wonder, well, why is that the case? Why would it have a higher price for a higher strike? We can go back and think about it and think of like, well, which of these would we rather have if somebody's like, hey, I'll give you a put with strike 10 or a put with strike 100. Which one would you rather receive as a gift? And we know that the put pays as long as the stock goes below the strike. So yeah, so we want the one with strike 100. Great, because this one has a whole lot more room to pay. It's going to pay anytime the stock is below 100. And so it's going to pay a whole lot more often. And if they both pay, then this one will actually even pay more. So that's kind of like the no-brainer choice. We would want the one with strike 100. That's one that's going to be more beneficial. So the higher the strike, the higher the value. So that's good. Okay, the other observation is that, well, the slopes kind of limit. They don't go, it doesn't go like infinitely steep. It sort of stabilizes at 1 or present value of 1. So what does that mean? We can kind of go back to, if we wanted to, we can sort of go back to algebra class where we do rise over run, right? So the slope, rise over run, so change in y, so put at K2 minus put at K1, the prices of those, Y2, Y1, over K2 minus K1, and that those limit at a 1. Well, 1 for American or present value of 1 for European. So I'll put here 1 for American and present value of 1 for put European. Okay, now the reason for that is because if I went from like, let's say $100 to 101, so the strike goes up by $1, but I can kind of think of like, well, how much would that extra dollar probably mean to me now? I mean, it's going to go up an extra $1, so it's not going to, I shouldn't really have to pay more than an extra $1, because in the future, the only thing is this one might pay up to an extra $1 versus this one. So it's only going to be worth maybe more. It might give me an extra $1 later. But it's like, well, there's even a probability with that. And then that's even in the future. So I might have to bring it back. So that's why it's like the extra $1 in strike won't mean a whole extra $1 in how much it's going to be worth to you or how much you should have to pay for it. So that's why the slope will never actually go up by more than 1, or the slope is never more than a 1. So just a quick reasoning on that. Now we actually want to look at this in a slightly different way. It's kind of nice to just, since K2 minus K1 is positive, I can multiply it over to the other side. So I actually have PK2 minus PK1 is less than or equal to, I'll just multiply this over to the other side. So it would actually be K2 minus K1 for an American put, or the present value of that. K2 minus K1 for a European put. Super nice. So I do see that the bounds here. So the difference in two puts should definitely be less than or equal to either the difference in strikes or present values, depending if it's American or European. Okay. And then observation 3 is interesting too. It just says that it's concave up, so it's bendy up. What does that mean? Well, that means if I actually had a third strike in there, then the second slope here would actually be more steep than the first slope. So the second slope here, put K3 minus put K2 over K3 minus K2 should actually be more than or equal to the slope through the greens. So put K2 minus put K1 over K2 minus K1. So that would be, you've probably even seen this inequality here, but sometimes like for a memorizing aid, it's just sort of like better, instead of having one more flashcard, maybe kind of like looking at the situation, having this picture, and you could kind of just get all these for free. Right, so just trying to help sort of put these things in perspective. But it is true that these actually are the right bounds, and they probably are on your formula sheet somehow. So for calls, we're going to kind of do the same sort of thing, but a call graph looks like this. That a call, so if I had strike 0, so if I have a strike of 0, you're like, oh, this call is going to be worth a lot. But because it's going to pay as long as it goes above the strike, and you're like, oh, if the strike is 0, it's always going to pay. So this thing's always going to be worth something. Man, that's like kind of best case scenario for me. So that's going to be where it's going to have its highest price, is if K is 0. And then from there, we know that it's not going to increase, it's just going to decrease. And it probably wouldn't be bendy like that, because that would feel like kind of wrong, because the strike could actually go up higher and higher and higher. The strike could be a gajillion, you know, so it would probably just be worth very little in that point. But it looks like, yeah, it should sort of decrease, but sort of be concave up. So again, this one's concave up, which is interesting, but it's no problem. Okay, first things first though, slope is negative, it decreases as we go. And again, there's this sort of limiting slope here. It's never worse than a -1. And for European, it would be the present value of -1, right? So, but it's no more steep than that. So the problem we're gonna have with this is all the negatives. So it's just gonna feel a little bit weird, but we're gonna do the same thing that we did last time. So the first thing is that, well, it's decreasing. So what does that mean? That means that the call at the second one, call at K2, would actually be less than or equal to call at K1. And we can think of that example. Well, would you rather have a strike of a 0 or a strike of 100? And you're like, oh man, I'd way much rather have a strike of a 0, because that's going to always pay, versus a strike of 100. The stock has to go above 100 for it to pay. So the lower the strike, the better for a call. So we see that. And then, okay, the slope. So this is going to be a little bit just awkward, but kind of bear with me here. But the slope is always greater than or equal to a negative. So the negative is going to be the hard part. So greater than or equal to a -1. So if it's greater than -1, that means it's like a -0.5, a -1/4. It means it's less steep, right? So it doesn't make it more steep because it's negative. So, but at any rate, we can write an equation for that slope. So that slope of that line is going to be, well, call at K2 minus call at K1 over K2 minus K1. Right. So that's the slope, right? Rise over run. In this case, it's negative, but that's okay. And we see that it should always be at least, well, a -1 or present value of -1 for call Americans or for call Europeans. But greater than a -1, it just feels awkward because of the negatives. But, and then I can multiply the K2 and K2 minus K1 to the other side. Actually, K2 is bigger than K1 here, so that's a positive number. I could just multiply it over, no problem. I get call at K2 minus call at K1 is greater than or equal to either negative K2 minus K1 or negative present value of K2 minus K1 for an American or a European call. Okay, so again, if you sort of run into problems on the test, you can rederive this if you want. But honestly, so the call at K2 is less than the call at K1, right? We know that. Actually, both sides are negative, so why don't we just negate both sides? So that'll kind of like switch around these. So I'll actually have call at K1 minus call at K2. And then the inequality was also have to switch less than or equal to K2 minus K1 or present value, K2 minus K1. So this is kind of the one to think of. And you can just sort of remember that it's opposite of the put. The put would actually, I mean, you still want K2 minus K1 or present value, that's fine. But for the put, it was the K2 minus the K1, call it put at K2 minus put at K1. For call, it's going to be call at K1 minus call at K2. Okay, but again, it kind of goes back to this whole idea about the slope. The slope should be less steep than a -1, which means it's actually bigger than the -1. The cool part is for the concavity, if I did the same sort of thing, K3, and I'd have some sort of third slope, it's actually, because both of them are concave up, it's actually the same exact equation as the other one. So I could actually do call at K3 minus call at K2 over K3 minus K2 would have to be more than or equal to, well, the one through the greens. Call at K2 minus call at K1 over K2 minus K1. But again, the slopes, as I move to the right, the higher the strikes, the slope should get larger, which in this case doesn't mean, it doesn't mean more steep, it just means less steep because it's negative. Okay, so just keep that in mind. All right, so let's, yeah, good. So let's do an example here with arbitrage. And unfortunately, well, I guess fortunately here, I did it with the call. So I could kind of show you how you can maybe handle the negatives. I don't know, it's always just a little bit awkward. You could just memorize and that's fine. Just want to try to help you to see sort of why or kind of what's happening. Just kind of like, just add a little bit to it here for you. So, okay, so here, example 6. So below are the premiums for 3 2-year European calls. If the current rate of interest is 6% effective, determine all possible arbitrage opportunities and explain how to exploit them. Okay, so now we have to think of like, all right, what can I use to exploit arbitrage? Because all they gave us was the prices for three different calls. They didn't tell me anything about the stock. They didn't tell me anything about puts. So I can't really use like put call parity. I can't really use those bounds we talked about at first where calls should be less than the current stock price or, you know, like the present value or the prepaid forward of the stock price or more than if I exercised it. So I don't know anything about the stock, so I can't even use that. The only thing I have are just like how calls relate to other calls possibly. So I kind of want to think back to this graph here where like, oh, okay, calls. So the price for calls decrease, concave up, slopes never worse than a -1. Okay, so just want to kind of see that. So, all right, well, let's see what we can say here. Well, first of all, do the call prices. So kind of observation number 1. Do the call prices decrease? So we could think back to that graph and we're like, all right, so I know that the call prices should decrease. Do they decrease as the strike goes up? And yeah, that's pretty easy to see. Yeah, so that one's actually all okay. So no arbitrage opportunities there. If I did have one that was lower than the other, or one that was higher than the other, but it shouldn't have been, well, then I could say, oh, I noticed that the one call is actually more than the other call that it shouldn't be. And then that's what I observe. And so I would know what to do from there, right? So you can actually, that would be an easy one to exploit. All right, what about observation number 2, where, well, I would need to know that the slopes were never worse than a -1, or I guess a present value of -1, since I'm dealing with a European. So let me actually just find out what's the present value of a -1. And then I'm just going to kind of do it off of slopes. So present value of -1 is -1, and then 6% effective for 2 years. So I guess I want to do over 1.06 squared. Yeah, let me just see what that is here. -0.889996. So, you know what, maybe I'll just say 89 cents. So -0.89. Maybe I'll just round it to there just to keep it kind of simple. So that's kind of accurate up to like 6 decimal places or something like that. Okay, but anyway, okay. So there's the observation. So the observation says that the slopes between any two, so I've actually got 3 pairs that I have to consider here, but the slopes always have to be greater than this number here. If they're ever worse than that, more steep, then that's bad. So let's I guess let's see what we got here. Let's do the 80 and 100. So I can do the slope through those two. So the slope would be their costs or over their strikes. So 13 minus 20 over 100 minus 80. So was that -7 over 20 is -0.35. That one's okay. Yeah, no problem, because it's actually larger than this. It's not more steep than -0.89, so we're good. It's more shallow, so that one's all right. What about 100, 110? So the 100, 110, I guess I would do 4 minus 13 over 110 minus 100. Let's see what we got there. 4 minus 13 over 10. -0.9. Ooh, that one is bad. Okay, that's gonna violate arbitrage, right? Because it's more steep than the threshold that I said. Okay, good. So that's a good thing to know. So actually, let me exploit the arbitrage. What would I have? Well, this is call at 110. That's the 4, because that is the call price, right? Call at 110 minus call at 100 over the 110 minus 100. So, and that actually turned out to be, well, it was -0.9. It was supposed to be a 0.89, but what was it? Well, it actually turned out to be even smaller than what it was supposed to. At -0.89. It was supposed to be larger, meaning less negative. So it's the hard part, the negatives. But it was actually, yeah, it was actually less than what it should be. It was more negative than what it was allowed to be for calls. Okay. But all right, that's great. It's actually real simple. I'm just going to multiply the 10 over to the other side, and I'm going to have call 110 minus call 100 is less than -8.9. So this is what I observed. And so for me to exploit arbitrage, my portfolio is super easy. I'm just going to move everything to the left-hand side. Most of it's already there anyway, but my portfolio will just be, I'll purchase a call at 110. I'll write a call at 100. And I will, long as lend $8.90. Okay. So, and then that's my portfolio, super easy. You could do cash flows, of course, like we said before. So I'll say here, sorry, that's kind of, see what I can move up here. So just for us, okay, so I would buy this one, write that one, and lend. Long is lend $8.90. Okay, no problem. And you can kind of see that, like, yeah, if I bought this one, but sold that one, so I'd have like $9 left over, but I could lend off $8.90 of it. So I kind of still kept it a dime. But then evidently in the future, there won't be any downside to that. So I'll always make this like dime every time. So, okay, good. So there was one arbitrage opportunity. All right, I still need to do the 80 with 110. Let me see how that one kind of works out. So the 80 with 110. And I've got 4 minus 20 over 110 minus 80. So 4 minus 20 over 30. So negative 16 over 30 gives me negative 0.533, and that one's okay. No problem. Okay, so that's okay. And then that was observation number 2. And I just want to go now and try observation number 3, which was the concavity argument. In other words, the slope with the later 2 should really be more than the slope from the earlier 2. But it's cool because I've already actually done those. I've already done those slopes. So the slope from the later 2, that was these two, the 100, 110. So it really should be that the later 2 slopes, negative 0.9, should be more than or equal to the earlier 2 slopes, the 80 and the 110. But I already computed that out, negative 0.35. But, oh, actually we see here there's a problem, right? Because negative 0.9 is not more than negative 0.35. It's actually the other way around. So I observe that, okay, the slope through these 2 was actually less than the slope through the other 2. So now I'm just going to kind of put it in with calls. The strikes I can put in as actual amounts. So call 110 minus call 100 over 110 minus 100, but I'll just kind of cut to the chase a little bit. So over 10, and then call at 100 minus call at 80 over 20 to 100 minus 80. And for me, I guess I could just multiply both sides by 20 to make it look a little bit nicer. So I'm going to have here 2 calls at 110 minus 2 calls at 100 less than call at 100 minus call at 80. Okay, so for me, what am I going to do? Portfolio. Well, I'm just gonna move everything to the left side so that just because that's where the arrow is pointing, and that'll tell me the portfolio that I would need. My portfolio is going to be, okay, well, let's see. Well, I guess we'll go lowest strike to highest strike. So we've got plus call at 80. And then how about the hundreds? I guess minus 3 calls at 100. And then plus 2 calls at 110. So interesting, that's a butterfly, right? An asymmetric butterfly. So we actually know the payoff in the future is always positive, and it's going to have the shape of an asymmetric butterfly. So probably if I thought about how much money I would get here, I would probably have a positive inflow at time 0, and then in the future, it's going to be a butterfly payoff, which we talked about yesterday, which is always 0 or more. So I'm actually always going to do good. And in fact, you can compute that out here. So 20 minus 3 times 13 plus 2 times 4. So if I found out the total cost, I remember cost follows the same sign pattern. So cost equals plus for longs minus for shorts. The cost is actually negative 11. I just computed it out. So I would kind of actually, so if it cost me negative 11, that's an extra $11 that I get. And then plus in the future, the payoff is a butterfly. So I'll have no downside there. So I'm actually making money. I see the arbitrage opportunity here. And what does that mean as far as the recipe goes? I guess I would buy this one, write 3 of that one, and then buy 2 of that one. And that would exploit the arbitrage opportunities for me. Okay. So, I mean, if you have different ways that you like to do those, if you just kind of like to stick back to the formulas, feel free, just kind of giving you a different way to think about it. But yeah, whichever ways kind of work out good. But it all kind of boils back down to the same few equations. Notice how I didn't really like go to this. I sort of did it more in terms of slopes. And I didn't really kind of start on this formula because I just sort of thought about it more, yeah, just in terms of kind of like the slopes in this graph. But again, if that's kind of too weird, too wonky for you, that's fine. Just go back to the formulas that you're comfortable with. It's totally cool with me. But the idea is still the same. It's just accomplishing it just different. All right, last topic today. Let's talk about early exercise, because this is always kind of a hot topic too. And I want you to understand what's going on here. And I'll kind of show you one slightly different way to think about these, but I don't really use that because I'm not that comfortable with it. But I'll just show you maybe a different way to think about early exercise. Okay. But you probably remember some formulas and some reasons why maybe, but I really want you to understand this concept. So we'll talk about what's going on here with sort of like the details here of why you would exercise a call early or why it might be optimal or whatever. So the idea is basically that as long as the benefits outweigh the costs or potential downsides, then yeah, you're gonna exercise it early. Okay. So we want to think of us. Let's say we're this like really savvy investor, and we're like really responsible with our money and stuff. And let's just start with calls here. So a call is an option to buy. It's an option to buy the stock. And let's say we entered it at time 0. And so we, as a savvy investor, we know that if we exercise it at the end, we're gonna have to pay K to exercise it. So what we would do is we would actually put in the bank, it's pretty cool, we would be so smart and we would put KE to the negative RT into the bank at that time. So over that time, it'll grow to exactly capital K, and we are so smart and we kind of can exercise it and have just the right amount of money and paying as little as possible. Okay. So, all right, so that's kind of our frame of mind as we go through this. So, all right, now let's think about the benefits and the costs or downsides to exercising early. So we think that, okay, if nothing else happens, maybe at the end we'll exercise and we'll get the stock. But there might be some point in the middle where, oh, I'm going to choose to exercise early. And for me, what would that mean? For a call, I guess that means that you would purchase the stock earlier than expected. Now, what would be the possible benefits of that? Well, if you were to actually get ownership of the stock here, then that means that like, oh, any dividends that would be paid here, you'd actually get instead of the other person getting, because you have them. Because you own the stock, then you've exercised it, you bought the stock, and that's what you got. So you actually are going to get the dividends. That's an added benefit. And that would be the only reason why you would do this, because you're like, wait, there's some dividends coming up, I want to get those. So you exercise early. Okay. Now, the downside to that, though, is that, well, okay, this account that you set up, you were expecting it to go all the way to the end to accumulate to K, but you actually you're not going to have enough money. So you're going to have to pay that extra, money early. So you're going to have to pay K early. So that's one downside to having to do it. You're gonna have to kind of take some of your own money because it didn't quite mature long enough, but that's fine. But then there's also this other idea about plus an implicit put. Now, I don't know about you, but that always kind of confused me. I'm like, well, what is this implicit put? But it makes perfect sense. So we're thinking of ourselves as like, okay, we are gonna, so if we actually were to purchase the stock early, then we get the stock, which awesome, we get the dividends. However, if we would have waited, it would have been like kind of like nice for us in the event that the stock just like tanked. What if I bought the stock and everything was going good, but then I don't know, like a huge recession hit or whatever, right? And then the stock just like plummeted in price. If I would not have exercised early, I would have made it all the way to the end and been like, oh man, I don't want this stock. The stock is terrible. I just want to walk away. Well, that's the implicit put. This ability for it to kind of have value if the price goes down, right? So if you exercise early, you kind of lose that ability to walk away later. So that's what they're talking about with this implicit put. It's this thing that has value if the price goes down, which you would have kept if you would have not exercised early, right? Does that make sense? That kind of makes sense what's going on there, but that's what they call this implicit put. That's the protection that you lose if you exercised early. You're not protected from the price going down. And there'll be a parallel idea for the puts, this, protection for the price going up. And so we've got that. Okay, so specifically, what do we need? Well, for this one, we actually need the present value of the dividends and this paying the K early. So present value of the dividends, if they're discrete, great, that's kind of easy. You're just going to kind of take them back. So you could just say like, okay, the present values of those. Paying K early, this sounds a little bit weird, but we could think of it as we're going to accumulate this, and then we're going to take K minus that. So we could think of that. But actually, kind of the nice thing is it's really an issue of do I pay K there or pay K here? And the difference of those is actually the difference that I'd have to pay for paying K early. So it'd actually be K minus KE to the negative R times the time. Now that is exactly the same thing as if I would have moved this forward, it would be this, and you can check that later if you want. But if I were to move that, and then it would be like K minus that amount moved forward. Just for these problems, it's a little bit easier to sort of think of it as, well, either I pay K now or I have to pull that K back, and that would be the difference. So it's a little easier to kind of see it like that. And the nice thing is that if discrete dividends were being paid, we know how to do that present value. If it were continuous dividends, it's going to have the same exact idea. It's a little bit weirder to think about, so we won't really do it here, but it's really just current price price at time T, and then T e to the negative delta times time. It kind of mimics this exact formula, but with delta instead of R and stock instead of K. But we're here at time T, so that's what we would kind of look for. But this is what we would mean by like the present value. This is the dividend thing we would think of if it was continuous. And then this implicit put, well, they would kind of have to tell us that value. It's not something that's easy to compute. For puts, by the way, it's going to be exactly the same parallel idea, but we're thinking now, all right, now we have to shift gears in our mind. Now we have an option to sell. So we have this stock. We can imagine that we already own the stock, right? So we own this stock. We're super savvy. We have the stock now. And so we think like, okay, what would be the benefit of selling it early? So sort of like the opposite here. In this case, I would actually receive the K early. So that would kind of be nice because I was thinking I'd have to wait all the way till the end to receive K, like if it gets exercised. So, but actually I can get K early, so then I can kind of put it in a bank and I can earn money so that at the end I'd end up with more than K. So that's a benefit. So I would receive K early. And the value of it would be exactly what we had here, K minus KE to the negative R times time. So that's cool. But the downside is that, well, if I exercise the put, and I sell it early. Well, I sold it, so now I no longer have it. So, okay, so I guess that's kind of bad because then um, I actually won't get the dividends here. So that's a downside because I already sold it, so I don't have I don't have it. So I'm gonna lose the dividends I would have gotten. So again, present value of the dividends. If it's discrete, easy. If it's continuous, it would just be this kind of formula here. And then there's going to be this whole plus implicit call, which means that I'm going to lose this sort of like protection for the price going up. Now, what would that mean for a put? Well, if I actually sold it early, well, that's great if the price went down. But if the price went up, oh man, I shouldn't have exercised it early, right? If the price kept going up and up and up and up, and if it was worth like $1 million later, but I sold it, oh, that's kind of a bummer. So I would love, I lose this sort of like protection from being able to wait all the way till the end and seeing if I even want to sell it for K. So I lose this protection for a price increase. Right? If the price goes up, that would have been good. If I exercise it early, I lose that ability to be able to keep the stock. Okay, so that's what they mean by this implicit call at the end. Now, we mentioned before that the put, or this implicit put, implicit call, it might be hard to price. I might not actually know the price of these things. So they sometimes phrase things in a weird way. Sometimes they say like, when is it optimal to exercise early, and when might it be optimal to exercise early? Now the difference is usually, will I know the price of the put and this implicit put and call or not? Because if I don't know it, then I don't really have all the information to be able to tell, was this greater than this? Well, I would really need to know, was that greater than this? But I really might not know all that. So the best I can do is say, well, it might be optimal to exercise early. I would just need to know how much those were before I could really tell you the answer. That's the thing that we got to do. So that's kind of the issue here. The other thing I just wanted to bring out is that you've probably heard that, like, oh, for no dividends, an American call or a European call equals an American call, right? So this screen actually shows us why that's the case. Because if I have a call, but there's no dividends, right? If there's no dividends, then there is actually no benefit for me to exercise the call early. This is a big fat zero, so there's no way that it's going to be greater than this right-hand side, no matter how small it is, right? So it's never optimal to exercise early. So because of that, then it's like, oh, an American call is kind of like, you're never going to exercise early. It's never optimal. So there's no benefit to ever having it. Having an American call versus a European, we're always going to, no rational person would exercise early. They'd always wait till the end, making it the same as a European. Okay. So just for what it's worth. Okay. All right, last question here then. And we'll kind of use this idea here, how we can get those values here. So, all right, so stock has a current price of 80, pays annual dividends, the next of which is in 1 month. So in 1 month, current price is 80, annual dividends, the next of the month. The current risk-free rate of interest is R equals 0.06. So Eugene has purchased a 1-year 82 strike. So I could go 1 year. Strike is 82. American call on the stock, and there's a dividend, so that's cool. Okay, good. So determine the minimum value of the dividend for which early exercise might be optimal. Not where is it optimal, because they actually didn't tell us anything about some implicit put here. So I've got that that's just X. And I want to know, and the best I can do is like, when might it be optimal? But I kind of need to know, like, how low could that dividend be worth for me to still kind of have some hope here? So we're going to actually do two things here. So one, we're going to think of Well, it's a call, so I would need to know it's going to be, it might be optimal if the dividends are more than the K being paid early. So I'm going to think of like, all right, what if I'm at time zero? So if I'm at time zero, so the dividends would be, the present value of the dividends, I guess, would be XE to the negative 0.06 over 12, 1 month's worth. But I would want to make sure that that's more than the present value of K being paid early. So in other words, I'd have to pay it now, 82. I have to pay the strike now versus getting it later. So minus 82e to the negative 0.06 times 1. Right, so I'm just going to think of like, well, I'd have to pay it now versus letting it wait. So now versus the present value of 82. All right, so let's see what we get here and what this tells us about X. X has to be greater than something. And I got like 4.480, basically, 4.799. Okay, well, that's it. That's there. But what if I'm actually at time 1 month? So let's say I'm at T equals 1 month. All right, now what? What could I say here? Well, if I'm here, then the present value of X is actually just X. So I guess I'm like immediately before the dividend is paid. So the present value of X is just X. And now I want to think of like, oh, okay, if I paid 82 versus like waiting to pay it, so 82e to the negative 0.06. And now I guess I've got what, 11 months to go here. So 11/12. Okay, so let's see, 82 minus 82e to the negative 0.06 times 11/12. So X is greater than 4.39. So I get a different answer. So I guess which one of these would I want here? And they said determine the minimum value. So if I thought about it at time zero, the dividend could be as low as 480, but if I waited a month and did it like right before, the value of the dividend could actually be as low as 439. So actually the dividend could be as low as 439 for it to be, might be optimal to exercise it early. So it kind of gets us at another point. You probably read about it and you probably already know this, but whenever deciding if it's optimal or not, it's always good to think of like immediately before a dividend is paid. After the dividend's paid, by the way, there would be no benefit anymore, right? So usually like right before the dividend pays, that's sort of like your best place to do it, that you want to wait all the way till there if possible. Okay. All right, but that's kind of all I had for today. So I'll stick around for a few minutes if you have any questions, but otherwise, thanks so much for joining us. Have a great week, and I'll see you guys next weekend. Okay, yeah, have a good one. Take it easy, guys. Keep up the good work.